Hey, this is Altus here at Math 7, looking today at parts of an expression. Just a little activity here to help you understand the different parts of an expression. So we have, first of all, and it says your terms, and terms are separated by plus and minus signs. So you can see here we have these various terms listed right here in this example, and they're all separated by a plus or a minus sign here. So in this case, we have 1, 2, 3, 4, 5, 6. We have 6 terms in this example here. Now within the terms, though, you have things like variable terms and you have constant terms. The ones that are variable terms are ones that are going to have a variable. Okay, now variable means they're going to have an x or a y or a z or some other letter that goes with that. Okay, now with that term, like for example here you have 16x. So 16x is an example of a variable term. Now with that, coming off of that, you have coefficients. Coefficients is the number next to the variable. So in this case here, the coefficient would be 16. So that's an example for how that works. Sometimes you also have constant terms. These are terms without a variable. So in this case, an example would be something like the number 10. It just is a 10. It's what it is. Okay? Now I'm not sure why this says exponents right here with a question mark. Maybe because sometimes you have things that have an exponent, and we have one here that has 9x squared. Just not sure why it's in this section with constant terms. But sometimes you do have exponents like the 9x squared. But the thing is that you have what are called like terms, and you have some that are not like. So in this case, this is a 9x squared, and it's not the same as 9x because x squared is not the same as x. So when we're talking about like terms, or we're talking about the variables being exactly the same with no different coefficients. So in our case here, 9x squared doesn't quite fit. The ones with like terms would be 16x and also the minus x. Those would work there. The coefficient for 16x is 16. The coefficient for minus x is actually a minus 1. That goes there. And then of course our constant terms, we have the minus 2 being there. So when you look at this one with 6 terms, we have a 1, 2, 3, 4, 5, 6. Oh yeah, we have 1, 2, 3, 4, and then we have, oh, forgot one, there's an 8 right there, and 8. My 6 terms are located in negative x, 16x, and I have 3 constant, 10, negative 2, and 8, and I have 1 exponent there. So those are my 6 terms and where they all kind of fit in the different categories. So some examples here, we have some examples, and it says to identify the terms, the like terms, the constant, and coefficients in each expression. So in this case here, I'd probably look and say I have 1, 2, 3 terms altogether. All right, those are my 3 terms. And I don't know if I want you to write the number 3, or if I want you to identify that 8x is a term, 2x is a term, and minus 3 is a term. Now the ones that are like terms are going to be the ones that are similar. So we would say 8x, and we would say 3x. Those are the ones that are like terms. The constant in this case is a minus 3. And the coefficient, the number in front of the variable, we have a couple of them, don't we? We have an 8 and we have a 3. So I'm guessing that's what they want you to write there. I'm not sure exactly. Okay, so let's look at the next one here. Not sure where that last one cut off. Sorry, I ran out of memory on my key and it cut me off there. So let's keep on going here. All right, so our next one, how many terms do we have? We have 1, 2, 3, 4 terms. Okay. Our like terms are going to be the ones with the variable x. We have x and minus 2x. So I can write them here, x and minus 2x. In terms of our constant, I have a minus 12 and a positive 22. And the coefficients, the numbers in front of the variables, there's a 1 in front of that x, and there's a minus 2 in front of that x there. And that's it for that one. Looking at number 3, we have 1, 2, 3, 4 terms once again. We have b as our variable, so my like terms are going to be minus 14b and also 3b. My constant term will be the 16 as well as the minus 18. And the numbers in front of the variables, I have a minus 14 and I have a positive 3. Let's look at a few more, look at some odd ones here. This next one we have 1, 2, 3, 4 terms. I have the ones with a p are my like terms. So we have a p and we have a 2p, and the constants are going to be minus 14 and a positive 5. The numbers in front of the variables, I have a 1 in front of that one always, so a 1, and I have a 2. For number 7, we see we have 1, 2, 3, 4, 5 terms. For the like terms, I see the y's. I have minus y, I have a 7y, and I have a minus 2y. Coefficients, I have constants, I have minus 6 and minus 10. And the coefficients, the numbers in front of the variable, we have a negative 1, we have a positive 7, and a negative 2. And for last one, number 9, I look here and I have 1, 2, 3, 4 terms. That's true. Do I have any like terms? Here I have a y and an x. Those are not alike. So I'm going to say that I don't have any. There are none. For my constant, I have 26 and minus 25. But I can still have a coefficient. And the number in front of the y is a minus 4. And the number in front of the x is a positive 1. Alright, so that's a good start for today. Hope that helps you out. And we'll look at the next notes in just a second. So here on the back side here, looking at ASI, Alta Sierra, Math 7, and taking a look at simplest form. So an algebraic expression is in simplest form if it has no like terms and no parentheses. Okay? And it says use the blank blank to combine like terms. I'm not sure what the blank blank is supposed to be because I didn't make this fill-in chart here. But let's do some work here and see what we can figure out. So in this case here, we have a 4y and a y. Now because they have the same variable, a y and a y, we can combine those. So we could say a 4y plus another y, which is 1y, becomes 4 plus 1, which is going to be 5y. Now you don't have to write 4 plus 1, I just wanted to show you how we added up the basic numbers there. Okay, so that's a 5y there. When you look at this one, we want to write expression simplest forms, we want to combine like terms. So what I notice is I see I have a 7x here, and I have a minus 7x here. So those are similar terms. So I have a 7x minus 7x, and then over here I have a minus 2 and a plus 2, or plus 6. So those are my constants. So 7x minus 7x becomes 0. It simply eliminates from each other. They eliminate each other. So I'm left with minus 2 plus 6, which becomes a positive 4. That's what's left there. All right. On the next one, we have 4z minus z. Now this is really 4z minus 1z. So because they're the same variable, we can say that these are like terms, we can combine them. 4 minus 1 is 3, so we're going to say 3z. For this next row, we have a 6. There's no other constant, so 6 is going to stay as 6. But here we have a minus 3n and a plus 3n, which means that simply means that they cancel each other out, and you're left with just 6. On the next one, we have a 2g and a minus 8g. So let's rewrite this as 2g minus 8g, and then we have our constants, minus 3 plus 11. So I can combine these ones here. So 2 minus 8 becomes minus 6g, and then we can combine our constants, minus 3 plus 11 becomes a positive 8. And there we have it in simplest forms. Okay, and next one. Here we have a minus 4j, and I have another minus 4j, so I can rewrite that as negative 4j minus another 4j, and then our constants, minus 1 plus 6. So these can combine to become a negative 8j, negative 4 minus 4 more is minus 8, and minus 1 plus 6, the positive 5. Alright, next one, here we have minus 3r, so let's write that as negative 3r minus 3r more, and then add our constants, plus 7 minus 12. We'll combine those like terms, becomes a minus 6r, and then 7 minus 12 is going to be negative 5. Here we have one constant, so that stays simply 2, and then we have 3d plus 1 more d for a total of 4 d's altogether. And on this one, we have 1n plus 4n minus 7n. These are all the same variables, so we can combine that whole thing. So 1 plus 4 is 5, 5 minus 7 is minus 2n, and the constant is just by itself, so it's minus 1. Alright, so here's a little word problem. It says you'd run m miles on Friday. So Friday you run m miles. the same amount on Saturday. So we did M on Friday, M on Saturday, and 4 miles on Sunday. And 4 on Sunday. So we did M on Friday, M on Saturday, and 4 on Sunday. Can you simplify this? Sure. We can combine our M's, so 1M plus 1M becomes 2M, and we keep the constant the same. Sal read B books in January, twice, so B books in January, twice the amount in February, so 2 times B in February, and 1 book in March. So that's January, February, March. So we can combine like terms. B plus 2B is going to be 3B plus the 1 in March is how many books he read. Alright, now we can apply this to something like perimeter. It says write an expression in simplest form for the perimeter of each figure. So let's do a few of these together. Alright, we have x's and we have y's. So the first thing we can do is we can combine our like terms. We have a 4x, a 5x, and a 2x. So this is 4x plus 5x plus 2x plus, and then here we have our y's, 2.8y plus 2.2y. When I combine my x's, I have 4 plus 5 is 9, plus 2 more is 11x, and I can add that to 2.8 plus 2.2 is 5y. So my solution becomes 11x plus 5y. Alright, I'm going to let you do the next one here on your own. If you look here, we have an A, we have B's and B's, and a constant as well. This one, just take a note, if it's 5a right there with that little line, that means this line is the same length, so this is also going to be 5a. But I'll let you do that one. Over here we have 4j, and 4j happens 1, 2, 3, 4 times, because this is the same hash mark there, right? This is 4j, 4j, 4j. So I could rewrite that as 4j plus 4j plus 4j plus 4j, it's a lot of j's, plus I have 2h right here, and because it has double lines, this is also 2h. So add another 2h. When we combine like terms, 4 plus 4 plus 4 plus 4 is 16j, and 2 plus 2 is 4, so 4h. And that becomes our simplest form for the perimeter of that shape there. Alright, let's do one more. We'll do the one down here in the middle. Here we have 4x minus 3, 4x minus 3, and we're going to add it to 4h plus 6. We're going to add it to 2x, and we're going to add it to 5h. So I put all that together. Now I'm going to combine some like terms. So 4x goes with the plus 2x, and 4 plus 2 is what? 6x. Now let's look at our h's. I have a 4h and a 5h. So 4 plus 5 is 9h. And then we have our constants. Minus 3 plus 6. 6 minus 3 is 3. And now we've combined that one as well. You can do the same thing for these other 3. Hopefully you can do those on your own, and it helps you out. Alright, see you next time.